Hey Kim, so today we are going to do part 1 of solution concentration. We are going to do part 1 because it's a very long section with a lot of math in it, and so I wanted to break it up into 2 halves. So we're going to do half 1 today, half 2 tomorrow. So, you learned about the process of solvation. Not salvation, that's Jesus. Solvation. And the factors that affect solubility. The concentration of a solution is the measure of how much solute is dissolved in a specific amount of solvent, or total solution. How would you describe the concentration of different solutions? So you can look at like the strength of tea or coffee. Usually the darker it is, the stronger it is. Concentration can be described qualitatively using concentrated or dilute. But in general, a concentrated solution contains a very large amount of solute, but a dilute solution contains a small amount of solute. So you can do percent by mass, percent by volume, molarity, molality, and mole fractions. That's kind of what we're going to be talking about. And there's a table on page 462 that's very helpful. It contains a lot of ratios in there for you. Okay? So, although qualitative descriptions of concentration can be useful, like how does the tea taste, strong or weak? Solutions, especially in chemistry, are more often described quantitatively. Some commonly used quantitative descriptions are percent by mass, percent by volume, molarity, or molality. These descriptions express concentration as a ratio of measured amounts of solute to solvent, or total solution. So you might be wondering if one description is preferable to another. The description used though is going to depend on the type of solution that you're analyzing, and why you're describing it. For example, a chemist referring to a reaction in an aqueous solution is going to use the molarity, because they need to know the number of particles that are going to be involved in the reaction. But let's talk about percent. Okay, so let's do percent by mass. And we should be very familiar with percent by mass and percent by volume. Those should be very simple concepts for you. So percent by mass is going to be your mass of solute divided by your mass of solution times 100. We've done this before. I hope to God you found percentages of other things before. It's just going to be part divided by whole times 100, the same way you'd find your score on a test, right? Total points divided by, or total points you got divided by total points you could have gotten times 100. Okay, so I'll do an example for you, and then we'll keep going. So in order to, this is example problem 15.2 on page 463. In order to maintain sodium chloride concentration similar to ocean water, an aquarium must contain 3.6 grams sodium chloride per 100 grams of water. What's the percent by mass in the solution? So, NaCl, 3.6 grams, total water, 100 grams. So 3.6 grams for every 100 grams. So which one's the solute and which one's the solvent? Well, the solute is, remember, what's going in. So the solute is going to be NaCl is going to equal 3.6 grams. The solvent, or the solution, is going to, so the solvent is going to be 100 grams. But now what's your total solution? Because your solution contains both of those things. So your solution isn't going to be 100 grams. This is the tricky part about this. This is the only part that might trip you up. So your total solution equals your solute plus your solvent equals 3.6 plus 100 equals 103.6 grams. So now we can go up to our percent by mass. Mass of solute is 3.6. Total mass of solution is 103.6 times 100, and you are going to end up with 3.5%. Okay, so make sure the number on the bottom is your mass of the whole solution, not just the solvent. So those are the first 3 problems in your GENOPOD. Then let's talk about percent by volume. Percent by volume is the exact same thing, but instead of grams, it's milliliters. Okay, so percent by volume equals volume of solute divided by volume of solution times 100. Okay? Same thing. Same thing. Don't go too far. So the next three problems in your Juno Pod are the same thing, percent by mass, but instead of percent by mass, it's percent by volume. Okay? So that's the first half. But now we're going to talk about molarity and prepping molar solutions. So I'm going to erase this. Okay, so what is molarity? I've used it a couple times in this lesson, but we haven't gone over what it is yet. So molarity, okay, so you've got percent by volume, percent by mass. Those are two ways of quantitatively describing the concentration of liquid solutions. One of the most common units of solution concentration is molarity. So molarity is a capital and italicized M. That's the number of moles of solute dissolved per liter of solution. Molarity is also known as molar concentration. The unit M is read as molar. So 1 M solution is said 1 molar. You don't say 1 M, you say 1 molar. A liter of solution containing 0.1 moles of solute is 0.1 molar solution. So to calculate your molarity, you have to know two things. You have to know the volume of the solution, and you have to know the amount, the moles, of the dissolved solute. Okay, so your equation for molarity, which is that capital italicized M, equals moles of solute divided by, specifically, liters of solution, total solution. Okay, so for example, suppose you need to calculate the molarity of 100 milliliters of an aqueous solution containing 0.05 moles of dissolved potassium chloride. So you first have to convert it to liters. You have to use liters. You can't use milliliters. Okay? So let's say we'll do two examples. You have 100 milliliters of solution, and there's 0.085 mole of potassium chloride. Yeah, okay. So you would first have to convert 100 milliliters to liters. So 100 milliliters, we want liters, so it's 1 liter over 1,000 milliliters, so equals 0.1 liter. So now you're going to divide it. So now we have 0.1 liter, so now we can plug it in up here. 0.085 divided by 0.1 equals 0.85 mole of the solution. Okay? So you need to know how many moles, but what happens if you're not given it in moles? What happens if you're given it in mass? Then you have to convert. Okay? So let's do one more practice problem for molarity. So let's say you've got a 100.5 milliliter IV solution. Okay? 100.5 milliliter solution. And it contains 5.1 grams of glucose. What is the molarity of the solution? Now, they very helpfully give you the molar mass of glucose. They tell you it's 180.16 molar mass of C6H12O6 equals 180.16. Yeah. So, first of all, we're given mass, we need moles, so we have to convert. All right? So, we have 5.1 grams of glucose times 180.16 grams per 1 mole. I'm sorry, I did that wrong. We already have grams, so grams needs to go on the bottom. So we want moles, so 1 mole per 180.16 grams. So we do 5.1 divided by 180.16. We end up with 0.0283 moles. Moles of glucose. That's our total. Okay? That's our number of moles. Now we need, so we know our number of moles of solute. Now we need to know liters of solution, but we were given it in milliliters, so we have to convert. 100.5 milliliters times, we want liters, so 1 liter over 1,000 milliliters. We end up with 0.1005 liters. So now we have the two things we need to plug in. All right, so our molar mass is 0.0, so molarity, 0.0283 mole, from there, divided by the liters of solution, 0.1005 liter. We end up with 0.282 m molar. All right, so that's how to do that. You need moles, you need liters, you divide them. That's it. Okay, so then you have a couple practice problems for that. Now, let's talk about how you make solutions, because when we use these solutions in the lab, a lot of times we have to make them ourselves. We might know we need a 0.1 molar HCl aqueous solution, but how do we make that? Okay, so I'm going to, now that you've got a moment to see this, pause it if you need to, I'm going to erase this. I'll leave the equation up there for you, or the ratio more properly. Okay, so preparing molar solutions. Now that you know how to calculate the molarity, how do you think you would prepare 1 liter of 1.5 molar aqueous solution of sucrose? Say you needed it for an experiment. Okay, so let's say you want 1 liter of 1.5 molar aqueous solution of sucrose, which is C12H22O11. Okay, a 1.5 molar aqueous solution of sucrose contains 1.5 moles of sucrose per every 1 liter. Okay, so this means that 1.5 moles of sucrose per 1 liter of solution. But we are asked, we want to know how many grams. Okay, so we know, so the molar mass of sucrose is going to be 342. Let's say you went to the back of your book and you added up 12 carbons, 22 hydrogens, and 11 oxygens. Okay, so your molar mass of sucrose is 342 grams. Now, if we need 1.5 moles per every 1 liter, 1.5 moles C12H22O11 times, we want grams, so 342 grams per every 1 mole of sucrose. 1.5 times 342 gives us 513. Okay, unfortunately though, we can't just dump in 513 grams. Okay, so just to review what just happened. We prepared our molar solution. We wanted 1 liter of 1.5 molar solution. We know that that means that there has to be 1.5 moles of sucrose in there. The molar mass of sucrose is that, so 1.5 moles of sucrose is going to be 513 grams of sucrose. But we can't just dump 513 grams of sugar into a liter of water. Why? Because sugar takes up space. If you add 513 grams to a liter of water, you're going to end up with far more than 1 liter, and we only want 1 liter. Therefore, you have to use slightly less than 1 liter, and you need to add enough sugar to make up that not only proper ratio, but to get it to equal 1 liter. So, there's some steps that you need to take. Generally, what you would do is you would measure out the mass of the solute to be used. Then you would place the solute in what's called a volumetric flask of the correct volume, which means that when the glass is full, it's the right volume. Then you add water in to bring it to the solution level. So let's say basically what you do is you get a 1 liter container. You figure out how much solute you need, you dump it in, and then you add water until it equals the right level. For example, let's say that you needed 1.5 moles of sucrose, okay? But you only need 100 milliliters. That means that you're only going to need 51.3 grams. Okay, so you would need to measure out 51.3 grams of sucrose to make 100 milliliters of a 1.5 mole solution. Okay, so to sum up briefly, when you're preparing a molar solution, you figure out what you want, you figure out how many moles you're going to need, and you use the molar mass to calculate the number of grams of solute that you would put in. Okay, so that's the first half. Tomorrow we will talk about how to dilute solutions. We will talk about molality, and we will talk about mole fractions. Okay, so your GenoPod contains practice problems for percent by mass, percent by volume, molarity, and prepping molar solutions. Okay, so good luck, and I will see you guys soon. Bye.